seems to be okay. Okay. So what are we doing today? So basically what we're dealing with today is something that has bugged me a lot for this one project and really like several projects I've been doing in Lean now, which is this sort of polynomials thing. Right. Basically, like in Lean, it's like very hard to get polynomials to sort of compute. Let me see if I can like demonstrate an example. So obviously I've already written a lot of stuff in this file, but if I say something like, and first of all, does this eval try to do evaluation polynomial? Yes, it has this type polynomial. Let's say where the ring is like the natural numbers. And in fact, I can just do something like polynomial at C1, right? This is a particular polynomial. Like even here, we get something like failed to compile definition. Consider marking it as non-computable. Because so it can't even like output that like when I try to evaluate this, it can't even sort of output it in a simple way because of these weird sort of non-computable things. So a lot of what I want to do is just to define a different type called polynomial with a little prime on it that is supposed to not have these issues. So like here, I've defined like polynomial prime.c. And if I write eval polynomial prime, like I can even like evaluate this polynomial like to a 1, 2, 3, right? So what exactly is this saying? This is basically saying that if I have the polynomial 1 plus 2x plus 3x squared, okay, obviously there's actually some sort of problem with it. But like the point is that I should be able to like evaluate this polynomial. Like polynomial C2, like you just get the list 2. That's fine. Basically, I want to like redefine this whole type. And hopefully I can like fix whatever my issue is with the eval here. And so I've like already done some of this with like, but a lot of these are just sort of garbage values. So basically the point of what I want to do today is just sort of go through this and eventually get to the point where I can define this instance and maybe go on and establish some like important algebraic equivalences between this and other types, which I might get to later. Okay, so how do I want to define polynomial evaluation? Right, this is the function that takes an element of some ring and then a polynomial in that ring. Well, okay, so first of all, maybe I should like provide a doc string for the type analogous to polynomial that supports computable operations. Yes, it already knows what I'm doing. Right, I'm going to say this polynomial is represented internally as a list. It's a list of coefficients. For example, the list 1, 2, 3 represents the polynomial 1 plus 2x plus 3x. Yes, correct. And maybe I'll just like put little things on this. Okay, so this is the polynomial representation that I have. Now I want to define eval, right? So what I want to do evaluates a polynomial at a given value, sure. Does it not want to complete? Evaluates polynomial at a given value, sure, cool. Okay, so I've done this with some sort of reversing and folding. I don't think this is exactly how I want to do it. Let me like consult. I think there's like list enum. There's like a function that returns a list to it. Yeah, this is basically like the enumerate function from Python. And this seems like a much more sound way. So I want to, so I have my polynomial P, which is in effect a list, and I have this R that I want to evaluate it at. What I would like to do is I would like to say P really is a list, so I want to take the enum of that list, right? A list that maps to a new list. dot fold L. Basically, what I want to do next is map this. So basically, I want to do like the map sum, and like just like this. Yes, this seems correct. Now, do you report the evaluation? Okay, so let's just check this. It says the evaluation is 17. So if I have the polynomial 1 plus 2x plus 3x squared, I evaluate that at 2. That is 12 plus 4 plus 1, which is in fact 17. Excellent. So that seems correct. Wonderful. Okay, so the next thing that I'm like proceeding to do now is to define a whole bunch of like values from the traditional polynomial namespace in Lean. So I have polynomial.eval. Polynomial.c is like the constant, it's the constant polynomial. So really, it should be this, right? It should be a single entry to the list, and it's R. Similarly, the polynomial x, right, is just the polynomial that has like a one coefficient on the first degree. So that's totally fine. Okay, what's next? Next, I have some things from the Lagrange basis, or the Lagrange namespace having to do with the Lagrange basis. And now it will probably be good for me to consult actual MATLAB to remember what all of this is, because basically I just translated all of these things. Lagrange nodal. Lagrange eval nodal. It doesn't actually give it to me. This is what I want. Yeah, it's sort of interesting how Moogle, I literally explicitly named the thing and it gave me a lemma. Maybe it's only programmed to return lemmas or theorems. That's interesting. So Lagrange nodal. Nodal is the unique monic polynomial whose roots are the nodes defined by the v and the s, right? So what do we have here? Right, basically, this is interesting. Is there even a way of making this computable? Yeah, because we're about to touch finset. And whenever you touch finset, I noticed that things begin to get really, really bad very quickly. So maybe I just want to delay these until later, please. I still want to define these, but not right now. I just want to do the basic operations first. Okay, so polynomial.add. Let me see if I can put this on a new line. I want to be able to add two polynomials. And here I've defined it as list.zipWidth, but I have a to-do fix because I think this is a wrong definition, because zipWidth, I believe, stops as the shorter list, which is not what we want to do. What we want to do is to extend the shorter list to be as long as the longer list. We want to extend it with zeros. List.extend, perhaps. I remember seeing this. There was, in fact, some function. It was in this match. It was list.match something. Match extend. I think the problem was it was in just some random library where it hadn't actually been moved to MATLAB or a place where it could actually be used. List is a version. This is maybe where Moogle will be helpful. I want something that's list zip with extend one list. Okay, zip. Combines two lists in a set of pairs. Longer list is truncated. That's not what I want. What I want, list.zipWidth is also not what I want. List.getZip is not what I want. What I want is an entirely different function on lists, which will... What I want is an entirely different function on lists that takes two lists Okay, there's like various ways it could be defined, right? I want something that will apply some operation on the first part of the list, and then some other operation on the rest of the list. It'll just like take what the rest of the list is. Basically, what I want is I want to like list.zip with PQ. What I really need is to like just extend. The thing is, I swear to God, I saw this. Where was it that I saw it? It was in the longest poll. Sorry, let me like consult here. I feel like I clicked on this, and then I clicked on this. Match length. This is it. CLI.list.match length. Matches the lengths of A and B by filling the shorter one with unit elements at the tail end. Right, so this is obviously like a function that would be very nice to have in like mainline MATLAB. So we're just gonna steal it. Over here. No, sorry, where am I? Back here. So stealing this function and putting it here. So this takes in two lists and a unit and extends it into a pair of lists. So what we want to do now, yeah, how easy will it be to prove things about this? I'm not sure. But what we want to do is say list.match length like let p prime q prime. I think this syntax is allowed. Let me just like see if this works. I would like to do list.match length, and then what I would like to do is return in list.zip with let this and this. Okay, I don't think I need the in, right? I think this is fine. I think this defines it, right? So like, let me just test this. Eval polynomial add these two things. What happens? So we have 1, 2, 3, and 4, 5, 6, 7. So the 1 and the 4 become 5, the 2 and the 5 become a 7, the 3 and the 6 become a 9, and then we have a 7 on the end. That looks exactly correct. Cool. Okay, now we have multiplication. So for multiplying two polynomials, this, like, I wonder if I have to do like casework here. So with multiplying polynomials, it's a little weird because it's all about, like, what we're actually doing here is not dealing with polynomials, because real polynomials can't have zeros on the end of the list that represents them, right? Like for a real polynomial, if I have a bunch of zeros on the end of the list, that's not supposed to be considered a distinct polynomial from a version of the polynomial that never has those zeros. And so like for this type, you get certain values that correspond to the same polynomial, but with different types, but with different like two polynomial primes don't like can sometimes map onto the same polynomial, and that's this sort of weird thing that turns out to be like a sort of a deep realization, like not a deep realization, but sort of a telling realization for the process of formalizing like cryptography, because in cryptography we only really deal with like lists. But what it means for the context in the context of multiplication. Yeah, what have I written here? Like, I don't think I actually wrote this. I think the AI probably wrote this. But let me just like take a look at what it has written. List.fold L A B A.add list.map. Like so in principle I could do something like what I don't necessarily want to do is anything too complicated. What I would like to do, sort of as it suggests, is I start, yes, so I start with the empty list, which is basically the zero polynomial. Yeah, it's not a problem. C, it's like the empty list, which is like the sort of zero nil polynomial. I mean, it's like the most nil polynomial you can get, even though you can technically have polynomials with zeros in them. And onto that, I will simply add a whole bunch of things. Namely, for each element of Q, I would like to add P multiplied through by Q. Is there such a thing as n, like n small? Maybe what I should do first is like n small. N small. Yes. No, is this for like naturals? But I want it like n small. Sorry, let me just like look up what is n small in the context of other things. Null, like polynomial. I think this is only for naturals. Like an n small is something scalar multiplication. Yeah, so it's like a scalar multiplication. Yeah, what I want is like s small. So what I want to define, let me like define s small first. Def polynomial dot s small. It's going to take in a semi-ring R, a polynomial P, and critically a ring element R. It's going to return a polynomial. This is scalar multiplication. What is it going to look like? You're going to map. Yes, that's exactly what it looks like. Great. Yes, list.map, every A goes to A times R. I mean, really, it would be a bit cleaner to do R times A here because we're multiplying on the left, I feel. Not sure if that matters, but okay. Now, what do we want to do with mul? Well, what we would like to do is we have list.full. So we're going to, for every element of P, what we would like to do is we would like to shift over R by some, do the scalar multiplication of R, and then like add all of those R shifts together. So list.fold L, I think I want to do like, so basically we're mapping over P here. What I think we want to actually map over is P list.fold L. Okay. Sorry, I just need to make sure I know the order of arguments here. Right, it takes in the last element. Basically the P is the last thing, but I can put it here. So now I have something equivalent to what the AI wrote. But what I want to do is I want to do the same like enum trick, perhaps. I want to do p.enum has type list nr, expected to have type r. So I want to take the p, like, again, the thing that I'm starting with is the empty list, and I'm adding a whole bunch of things onto it. Sum. Right. I mean, I actually do want the capability of like summing things. Maybe it would be better if this were all like represented that way as like a sum of polynomials. I'm not sure what the like best way of structuring that is. Polynomial prime dot mul. It's always very hard to predict. Basically, list argument. Right. So sorry. I think we fold L. We have the init value first. Is fold L really the like more dominant? Fold L is more common than fold R? Where is fold R defined? Init list B A. Yeah, okay, I guess that makes sense. End is in the right order. We're folding onto the left. So the function that we're applying is of type alpha to beta to alpha. Beta here, I think this is what like n comma beta is what needs to happen. Unused variable, so that seems to be the right type. And what are we doing? So we have A, which is what we have so far, and we want to take A and add onto it B, yes, B is the thing that we want to shift, so we want to do like polynomial prime dot n or dot s small of B, sorry, A is what we have already. Q is something we need to reference as well. What we want to do is we want to take Q, the n small of B and Q, I believe. B and Q. And like furthermore, this is something that we want to shift left by, we want to basically do like list dot replicate 0 n times plus plus this. Sorry, do I have the wrong? Fail to synthesize instance. Can I do like polynomial prime dot make? Oh, how do I actually get the polynomial from the list? Like what's new in? Does this tell me how to do it? Polynomial, all messages. Does this tell me? No. Annoying. How do I def? Yes. This is exactly right, right? This is a list and I get a polynomial. Okay, so now that exists, whatever it was supposed to do. Fail to synthesize instance. Am I not enclosing correctly? Polynomial n versus polynomial r. Okay, I see the issue. The issue is that this is a 0, so we're replicating, sorry. Can I see the documentation for list.replicate, please? List replicate. Yeah, frustrating that it doesn't. List.replicate, what's the order of arguments here? N is a natural number. A is the value that we replicate. So n times is how many times we want to replicate. 0 is the value. 0 of type R is the value. Fail to, yes, of course it fails to synthesize instance. I see what my issue is. Like to list, I just need to like convert back to list. Sorry, dot to list. Okay, what I want to do now is not do this at all. What I want to do is I want to list.replicate, append that to the polynomial small, which has been converted back to a list, to list. Too many parentheses. What are you complaining about now? Come on, just another set of parentheses maybe? Yeah. I feel like I have redundant parentheses somewhere, but who cares? This seems like what polynomial.mul should look like. So just like again to like evaluate this eval Polynomial.mul, 1, 2, 3, 4. What does it say it equals? 3, 10, 8. Does that make sense? So 1 plus 2x and 3 plus 4x. 2, 4, that becomes 8, yes. 1, 3, that becomes 3. 1, 4 plus 2, 3 equals 10. That looks correct. Brilliant. So now we have negation. I'm pretty sure this is correct. We just map multiplication by -1. Subtraction is adding the negative. Taking the power is just multiplying a bunch of times. List.foldl. List.replicate n p's together. Yes. Yeah, starts with 1, and then we just multiply on p a whole bunch of times. That makes sense to me. We need to implement polynomial division. Yeah, this is a little bit tricky. So polynomial division. Right. This is something, I mean, like, this is one of those things where it's clear how you divide by a monic polynomial. Does it really like semi-ring? Let me look up polynomial.div. Polynomial div requires a field. Okay, so I'm happy to require a field here. And mod also requires a field. Remainder of polynomial division, see mod by monic for more details. Okay, division of polynomials. What's the equation here? Div equals polynomial c, polynomial.leading coef, q inverse times so it's defined in terms of mod by monic. Let me click on mod by monic. Maybe I just want to replicate the definition of div by monic here. Yes, and these are of course defined in terms of div mod by monic aux. Yes, so what will be the fastest way of replicating all of these? You know, it's actually the case that I'm not sure that these are necessarily needed right now. So this is like another thing where it's like semi-necessary for what I need to do, but not critical for the next step. These instances will go forward in time as well. All of these things will go forward to here. Sorry, wait, why is it complaining? Failed to synthesize rings. Yeah, field. So these should all be field. Field. Div x. You should be field. I mean, this is being defined in terms of p.div polynomial c1. But there's a cleaner way. I think I'm just gonna quickly fix this, right? This is like tail, right? This is the tail operation. p.toList.tail exclamation point dot make. To list, yes, cool. I think that's correct, cool. But I mainly want to ignore those things as I proceed to define all of the instances, right? Okay, so if R is a semi-ring, then we have zeros, ones, addition, and multiplication, and also negation and subtraction. And also the power function. Semi-ring. And we seem to have defined an inhabitant instance, presumably because we needed that at some point. What we would like to do now is define, right? So this is the thing, right? If I go to polynomial, so I would like to define the com semi-ring instance for polynomials. If I go to polynomial, com semi-ring, and I go to how it is defined, I get this thing that I do not understand at all, which is like they've put this. I don't understand what these declarations are. Function injective com semiroop to finsup. Yeah, just like totally mysterious. Can I mean, so maybe the point is that they define something else first. So they define com semi-ring. In principle, does it even need commutativity? I feel like polynomials generally need commutativity, but I feel like that's something that's left out. Like it's a semi-ring R. It's polynomial semi-ring R. And it seems to be completely comfortable with the fact that the ring might not be commutative, which is sort of strange. Because that's not the case for multivariable polynomials, because in multivariable polynomials, you're doing like all sorts of, commutative multiplication. It's, yeah. But so like returning to where I was, we have all these instances that I have now defined. So like what they define here, maybe if I just like keep going, the private definitions are actually exposed, simplify them away. Yes, so they've like got private definitions apparently. Private add, private. Instance add prime equals add Rx. These are all private definitions. Seems a little mul equals mul. Yeah, very like strange and disturbing that to like see this as like, ooh, oh no, this is a mistake that you could easily make. So maybe I should maybe all these definitions should be like private or something. Irreducible def is, who knows what that syntax means. Let's just try like writing this instance. Instance small 0 class R semi-ring small 0 class sorry, this needs to be S small 0 class sorry, S small 0 class. It has SR. SR. Then there's an S small 0 class from S to polynomial R. Where is the way it proceeds to define where S small RP equals P dot to finsub. I see the thing I think is that it's like identified with P with to finsub. S small 0 class. Is it really necessary to do all this? What actually happens here? Sorry, there was some, okay, yeah, there was some extremely strange thing that I was getting. It was complaining about something. Look at what it complains about. Messages. Hello, please show me. Unexpected token where? Expected term. Yeah, sorry, I need to delete this too, but if I delete that, type.mismatch if-if.refl. Like what? Where was if-if.refl mentioned? Is that like a lemma in the library? Sorry, if I go back, IFF refl. So this is like some theorem. A implies A. Type mismatch has type this equals this, but is expected to have type that. Oh Lord, how do I even turn this into a minimal working error? Such a pain. Like this is definitely not a helpful error. I think I basically just want to like how can I technically even minimize this error even more than it's already minimized? I can't, right? It's basically like I need all of these things to be able to define this. Maybe I can delete like the power. Okay. Okay, so I'm just gonna copy this and we'll see about minimizing it. Oh my god, it's Zulip. Zulip is the name of this thing. Okay, I want to start a new not in general. I want to go to like lean for, I guess. Now start a new conversation. Type mismatch IFF ruffle in, what am I trying to do? In like instance definition. Copy and paste the code. I am trying to define an alternative structure for polynomials that can be more easily computed with. When I get to proving this type is a semi-ring, com semi-ring, it gives me an error saying there is a type mismatch on IFF.ruffle. But I don't see how I am using that lemma. I mean, like the answer is that it's like somehow implicitly being used, but I want to like understand how I can avoid that. I don't understand how I'm using that lemma. How can I avoid this error? Question mark. Send. Let's see, I worry that it's like something to do. I go back. Com ring is fine. Basically, it's once you have the ring, it's not hard. I want com semi-ring. Function injective com semi-rip. Is the point, let me like try and like parse out what is exactly happening here. Can I duplicate the tab? Yeah. This is going to be something where it's like the underlying, it's like telling it, please interpret this according to the underlying, like fin subtype. Because polynomial, like underneath the hood, the traditional polynomial underneath the hood is like a fin sub. Function injective com semigroup. If f is an injective function, and we have this distributivity that the function f distributes over multiplication, then there's a com semigroup instance on M1 commutative semigroup. A type, sorry, let me just read the doc. A type endowed with multiplication is commutative semigroup if it admits an injective map that preserves to a commutative semigroup. Yes, okay, this makes sense to me. It's like I defer, but basically, okay, it's an injective function, which means that there's a bijection between M1 and some subset of M2. M2 obeys commutativity of multiplication. Therefore, I can establish, this bijection, and I say that, like, okay, it's according to the bijection. But this is completely unhelpful to me because I do not have a function, right? I am not defining, right? Like my polynomials are not functions, they are lists. And therefore I will have to do this the hard way. Like maybe that's the point. Semi-ring. So maybe what I want to do, yeah, I'm a bit worried that the recording cut out there for a moment, but what I want to do potentially is just go for com semigroup first. Can I do that? Instance. If it's a semi-ring, I don't really care about it being non-commutative. If it's a com semi-ring, although of course, like the MathLab people would probably make me change it if it's wrong. Com semigroup, where, how do I make it do its like magic? Fields missing, Mollisock, Molcom. Okay. I mean, at least it's not complaining now, so now I just have to like prove some things, I guess. Right, so Mollisock, ABC. Sorry. Like I just have to prove these are polynomials, right? And I have multiplication on them. Now I just have to prove that, now I just have to prove this statement. Which is maybe a little difficult. Yes, potentially some like casework to be done here. Induction A, generalizing BC. Yes, I see what it's like trying to like tempt me into doing now. It's trying to get me to be like, oh, go ahead and define like div x, right? This div, it's sort of funny. This down here is like this tail function. And in principle, I could also write like a const, like something that would get the like the head to, and I could just like turn everything into a list. And I could do induction on A. Induction A, generalizing BC. Case nil simp. Simp made no progress. I mean, nil is the zero polynomial. It's list.nil. But of course, it's being converted to a polynomial somehow. I'm a little wait, why is there like an unused variable here? Let me like look carefully. List.fold A multiply P. B is a polynomial. I mean, this is, I guess the reason is that like this does not actually have to be a replication of P times that. It just has to be multiplied P times. This is maybe more complicated a definition than it needs to be. To do complicated than it needs to be. It's interesting that this type is in purple and the other types are in blue. It must be because it's an explicit argument. This is because I haven't like proved zero mul yet or something. Ugh. So frustrating that I have to like reprove all of this. Like, what happens if I prove like zero mul? Let me just like prove a theorem. Quick lemma here. Lemma. Polynomial dot zero mul. Induction P. Simp. Unfold mul. Simp. Huh. Okay, the problem is that it's like, problem is that it's realizing that I'm doing a bunch of addition. Yes. The problem is that it's realized I'm doing like matched length or whatever. What am I doing here? Sure. Try simp only. List dot replicate. Yeah, so it sees what I'm doing. Add. Yeah, I still sort of don't see how this became such a big deal. I unfolded mul. So I just am multiplying these two things here, right? Mul, polynomial. If I unfold it, why is it unfolding the list.replicate part? What I would like it to do Okay, no, there's a list.replicate here. What am I saying? There's an add here. Okay, there's an add here. List.replicate n. Perhaps I want to like do this in a different way. Commutativity of multiplication is going to be difficult. What I would like to do most is just prove that this is the case from its okay, am I literally staring at the function that I need? Just a moment. Function injective com semigroup. Function injective com semigroup. Okay, this isn't it, but this is close. Okay. Ooh. Moving my timetables forward. Okay, by the way, I should check if like someone has answered this question. No one will know what the answer is, whatever. Okay. I am realizing that if only I had an injective function from this type to a known com semigroup, things would be much easier for me. And it was in fact my goal with all of this, as I was going to reveal later, but I will now reveal now. There is this file with the tropically bound polynomials. I may have discussed this in like a previous stream, but I like unfortunately deleted all of my stuff that I had like I had like tried to like make this file better, but I like accidentally deleted it because for some reason the MATLAB repository does not know how to like not generate huge numbers of extraneous files every time I like do a git operation. I don't really know what that's about. Nevertheless, we have this semi-ring. Does it matter that this is non-computable? So this is the type of tropically bound of polynomials with a bound on their degree. Like polynomials augmented with a bound on their degree. And it is in fact a semi-ring. In fact, it should be a com semi-ring. Yes, but the point, so this is a com semigroup, but there should be something analogous for semi-rings, I feel. Let me see if we can find that. Function injective semi-ring. Function injective semi-ring. Sorry, injective. Function injective semi-ring, yes. And com semi-ring as well. Yes, we want more power if possible. Com semi-ring. In fact, we can do like com ring, right? If we provide all of these so we can do com semi-ring and basically, yeah, function injective com ring. This is what we want anyway. We just want to like establish this this function here. This is interesting. So if we can establish this, and I think the point is, even though this is non-computable, I think all of the operations are still going to be computable, right? It's going to be perfectly possible for me to continue using the add function, which I know already works. All right, let me just like make sure that the add function, like if I do eval polynomial, sorry, if I like do polynomial.make plus, this is fine, yeah, 2, 4, 6. I should maybe like think about like better I could like think about making like a nice pretty printer or something for this, I think. But I won't do that now. So I can, but it's perfectly fine to do addition. It's not going to like interfere with anything that this is all totally non-computable. I just want to establish the fact that it's a semigroup, a commutative ring or whatever. I think I'll just do it at the level of commutative ring. Okay, this is interesting. So what I'm actually going to do is I'm just going to delete all of this. If I can competently like select. What I want to do, it is an instance given a com ring. How do I capitalize it? Com capital R ring. Then we have a com ring for this, which is as follows. It is what we get from function .injective.com ring. Okay, and we've reached the point where we now have to import this other file. What's this file called? PyOps math tropically bound polynomials. Import PyOps dot math dot tropically bound polynomials. Restart the file. And it'll compile for a while. Okay, but now we need to move forward. So the first thing that I provide is a function. And this function is supposed to be from the polynomial prime type to this type. Sorry, where is it defined? Tropically bound poly, this type, yes. Sorry, like what if it's like check? Yeah, a sub-semi-ring. I mean, I think it's technically like castable to a type. Tropically bound poly. So, yes, the function like, okay, so now I must define this function. Polynomial prime dot, okay, well this is probably wise. Sorry, tropically bound poly, tropical order dual with bot n. With bot n, this is really the degree, right? Order, yeah, the degree, this is the degree, not the not degree. It's less than the tropical, the untropicalization. I mean, in principle, I just actually have to establish this. I don't have to, what I definitely don't actually have to do is make it go to this type. I can actually just make it go to this type. So what I'm going to do first, okay, backing up, def polynomial prime dot to poly dot to poly. Sorry. And then I want the degree bound. I want it to map to a with botnet. I'm pretty sure it's with bot, right? Like, sorry, I'll look up quickly. Polynomial.degree with botnet, yes. So both of these. So I'll define both of these. Then I will define, what just happened there? Sorry. Yeah, so like an empty list should go to the bottom. A list with one element should map to a degree bound of 0. It should be the natural like correspondence. And then what I want is polynomial dot to tropically bound polynomial. I don't even need it to be this type. I can make it be this type. The thing it returns will be of this type. Sorry. And it will be defined in terms of these two things. And then the function, so comring, okay, going back here. Okay, wow. This comring function takes as an input this f. And the f that I want is simply this function. Simply this. Unknown identifier. Okay, wait. Unknown identifier. Import. Okay. Unknown identifier. Why is it still saying it's an unknown identifier? It's because there's no capital I. Fail to synthesize. Okay, but there's lots of things that have to happen here. Like I need this. I need something here. Okay, so I need injectiveness. I need 0. I need mul. So I need add. I need mul. I need n small. I need z small. And then I would be good. But it's saying I failed to synthesize the instance small and what? For polynomial prime. Sorry, like we understand we're doing polynomial prime r, right? What is it saying I need to synthesize? Small n polynomial. Okay, small n, but I did define this. So instance. Sorry, this one instance is a little bit different from the others, so I'm just going to put it up top. In stats, this is not quite has COE, sure, but it's not what I want. I want n small. What is it? Small n polynomial prime r. Small n polynomial prime r. Small. Maybe it should be n small? Why is it not inferring types? Yes, has type this, but is expected to have small. Sorry, what is small? Okay, wait, no. This is the small. This is the scalar multiplication, but I want to be multiplying by naturals. small n. Maybe I need to do like n small. N small is defined as R is a natural number. It seems completely comfortable with the fact that R can be a R here and R can be a natural number here. Just gonna not confuse myself. Okay, so it should be n small. Is this happy? Yeah, now that's happy. So there's small from n to this, yes. Are you still complaining? Failed to synthesize instance small z. Is there like just polynomial n small. Small. Yeah, not totally certain. What happens if I literally copy it and do z small? So z small is a z. Fail to synthesize instance. What if I say you're a ring and not a semi-ring? Now you're happy. And what do you, so, and now I claim small z, z small. Fail to synthesize, okay, of course you need to be a ring. Now what are you unhappy about? Nat cast. Okay. I can cast a natural number. Sorry, I can do nat cast. Nat cast is it just takes one argument. Yep. Correct. Now what? Int cast. This should be a ring. Int cast. Yep. Seems fine to me. What do you want now? Type mismatch. Okay, so we finally got to the point of complaining that I haven't provided anything. Sorry, wait, if I just do like sorries for all of these. D, sorry. Wait. Okay, now I'm confused about why it's complaining. So comring, sorry, we have comring. This is F. That's F, right? So we have 0. I need more things. I have 0, 0, 1, add, mul, sub, n small, z small, npow, natcast, intcast. I need 10 sorries. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You still complain. Type mismatch. Has type for all n. Sorry, I can't even need to like expand the size. Type mismatch. Function injective comring. Has type. Do I need to like tell it what R is? Beta equals R. Can I do this? Beta is R. What do you complain? Comring polynomial R. What? Has type for all n equals n. Can I declare alpha too? Sorry. Right? It has like two function types that I did. Like, do I need to add two more mysterious sorries here? Function injective comring has type comring R, but is expected to have. I'm just very dumb. I need to put polynomial prime arc here. Yes. Of course. Failed to synthesize instance comring. Yes, because over here we did not prove that. Okay. Can this, okay, so sorry, this says example. I don't want it to be example. I want it to be an instance. Inst, yeah. And I would additionally like to say that a com semiring. So, yeah, sorry, fucking variables are dumb. I'm gonna do instance R semiring R. And we have a semiring here. It's also the case that we have a semiring here. And furthermore, if we have that R is a com semiring, that's fine. Can you additionally infer, please, that if it's a com ring, then it's a com ring? Com ring. Failed to synthesize instance. Commutative ring. Yes, the issue is that it's not a com ring or something. Let me just think. It's not a com ring. Right, I remember this. It's not a com ring. It's only a semi-ring because you don't actually have the property that when you add, when you subtract something from itself, you get 0. Because the 0 is the nil, super nil element, but when you subtract something from yourself, you might get a list of zeros. So this is not actually a com semi-ring. Okay, so I need to revise what I'm doing here. It's not a com semi-ring. I don't even need it to, okay. Speaking correctly, it is not a ring. It is not, it is not a commutative ring. I don't need it to be a commutative ring. What I need it to be is a commutative semi-ring. This is complicated. Let me think. If I like, does it respect a ring? I wonder. No. So I can make it a commutative semi-ring. It's not going to be the case though that subtraction is well behaved in terms of subtracting things equals 0. So yes, I just have to like put it out of my mind that that's something I could want and just go for com semi-ring. Okay, so I can only do com semi-ring. Let's copy, paste, com semi-ring, function injective com semi-ring. I think it's spelled like this. Two tropically bound polynomial. Sorry, where is com? I'm sure it must be defined here. Function injective com semi-ring. Function expected. That suggests there's too many sorries, so delete. Okay, now it seems to be happy. Uses sorry, but it's happy. And if I put my cursor here, yes, so it wants function injective. Yes, we can do all of these things. I mean, the point, like, it's function injective. Sorry, what do we want? Like, yeah, the 0 maps to 0, the 1 maps to 1. Yes, two tropically bound polynomial. Just have to like introduce things. I wonder how hard these proofs will be. But the point, perhaps, is now that I have the com semi-ring instance, and I have all of the operations that I want to do, right? Is it even like necessary to proceed? I think it might not even be necessary for the rest of my code base to keep doing this, but I still sort of want to do it anyway, just so that I can like feel like everything is sorry free. By Ruffle. I see that this is what I was. I wonder if it was like implicitly doing this, you know? It's like very funny. Did they respond to my? No. Okay. By Ruffle. I don't know what the difference between Ruffle and Ruffle. I would like to start proving. Unexpected token? What? Should I be? Sorry, can I, like, what's going on here? Can't intro, yeah. Unfold is what I want to do. Unfold. To tropically bound polynomial, which of course won't work because it's started out. Okay, but like, so clearly I should be able to like write this function, right? What happens if the AI's polynomial.toPoly, yes, that's what I want there. Tropical.make, order dual.make, polynomial.degreeBound P. Well, this is definitely right. Unknown tropical.make. It's like trop and untrop or something. I think that this is like trop. Tropical.trop. And this is order dual. Order dual. There's something that like maps something to its order dual. What is that? Order dual. Order dual. Order dual. Instances, thank you. Sorry, I can't see anything. Is it like two order dual? Is it order dual 2? Order dual to dual? Of dual to dual? These are functions. In fact, they're equivalences, but they're functions. I think it's like to dual. Order dual dot to dual. To dual. Wonderful. This seems to be correct. Now I simply have to define these other things. Let me define these. P dot length minus 1 of type n. This is not right though. What we really need to do is cases p dot length, or like match, I think it's like match p dot length with so I think this is correct, right? If the length of the polynomial is 0, then that's the bottom degree. Otherwise, it's a natural degree, right? If the length is 1, then that's a constant polynomial. Polynomial, therefore, is 0 degree. Yes, seems right. Polynomial dot to poly. Wonder if the AI will polynomial dot make. No, that's not right. Um, um, there's some like very clean way of defining like if I have a map to like the x value. No, but that doesn't work. But it has to be something like I have to do some sort of like sum eval. Evaluate a polynomial at a given value. See, like the real cool thing, there's like eval2. Sorry, I go to like polynomial dot eval2. Let's see, that's a little bit annoying, by the way. Polynomial dot eval. You can see that there's polynomial eval sub 2 here. But can I do like underscore 2? There's no way of like getting that. Because it's this. What this does is evaluates a polynomial given a ring hom from the scalar ring to the target and a value x. So why don't I like define this? Is this correct? Takes a semiring R and a semiring S1. I don't know why it's S1. We're just going to make it S. A function from R to S. X. Let's just make it match, please. X of S. P will be a polynomial of type R. Yeah, we're evaluating it at S. It'll be something of type S, and the function is going to be something like, okay, is this correct? Right, so every coefficient we will be mapping to the target ring and multiplying by x to that power, summing over all of those. This seems like the correct definition to me. And now to define the conversion to a polynomial, it's going to be polynomial prime dot eval2 I have to think. It's always a little tricky to get all of these right. So R, yes. I have a polynomial prime over R, and I want to convert it to a polynomial over R. So R is R, and polynomial R, like classic polynomial R is S. I want to evaluate my polynomial prime R at the value S, which is polynomial X. That looks right. P is the polynomial I want to evaluate at, and the only other thing is the function, which should be a map from R to polynomials over R. Oh my god, I've confused myself. Where am I in the file? It should be a map from R to polynomials over R. R is a polynomial. Why is this? Shouldn't the input be something like R to polynomial R? R of type R maps to polynomial.c of R. Don't know how to synthesize implicit argument. So, it's always so, like, let me just like check that I'm doing things right. What I said is that the R value of the polynomial prime eval 2 is R, and the S is this. What is it? Polynomial prime, compiler IR check failed. Declaration polynomial semiring. Yes, I mean, okay, so maybe this is okay. I just have to say non-computable, and it's totally okay that all of these are non-computable again, because this is this is not data, right? This is we're in theorem land now. Non-computable. Non-computable. These instances are non-computable, but no one cares. Is that okay? Is it okay that it's a non-computable instance? It's a non-computable instance. It's a non-computable instance with lots of stars in the def, but that shouldn't matter. It's a non-computable instance, but like all of my functions are fine. Does this cause like massive problems down the road? Let me just like quickly go over. This is not the file. What is the file? This file, maybe. No, this file doesn't exist. Like the Marlin protocol file. Restart file. Some error that it's going to give. We'll see what happens. Right, it's like, in principle, all of the operations are computable. Fail to compile, yes, all of these things are communicating that they're not computable. Unknown declaration, inst-con semi-ring polynomial to semi-ring. It's interesting that these guys don't seem to care. Matrix. Is this the first one that involves like polynomial over F? Do these guys field F? IRI check failed. So frustrating. How is it? Compiler IR check failed. Unknown declaration, inst com semi-ring polynomial to semi-ring. Like, how do they expect this language to be usable for program verification if these basic things are not working? I guess the point is that nobody else in the entire world literally at all has to care about like the fact that its things are fields. Okay. Lynch, yeah, the problem. Unknown declaration to semi-ring. What? It's not like, it's not made more clear by the fact that like to semi-ring is not something I have. Polynomial prime. two semi-ring. F is a field. Why does it need like semi-ring properties? There should be nothing going on. Okay, it's actually complaining about NV polynomial, which is slightly more encouraging. It's complaining about something else. It's complaining about this other stuff. So maybe actually everything is like great. Maybe everything is just golden, because this guy has the polynomial, right? And it does not seem to care at all about what's going on here. It feels totally happy. It's only when I get to the multivariable polynomial, for which I haven't done any of this, that it gets to be unhappy. So maybe if I fix NV polynomial, that provides its own problems. Non-computable instance. It shouldn't be a problem, right? It's just like a fact that it's just the fact that it's a COM semi-ring. Non-computable instance. It's just weird to think of it as a non-computable instance, because all of the operations of the COM semi-ring, yeah, it's not like all of the operations of the COM semi-ring are totally computable. It's just like the theorems about it that we're getting from this all this function injective COM semi-ring thing does is like prove the theorems. Like prove the distributivity, prove the like commutativity, prove for multiplication and for addition. All of those things. So it seems possible. Yeah. Still a little bit nervous about it. Let me look at the NV polynomial. Right, for NV polynomial, we have a harder problem ahead of us, because an NV polynomials are fundamentally different. Yes, the problem is the thing that I did for multivariable polynomials. Like, okay, so like I made my computable polynomial, and then I was like, okay, I need computable NV polynomial too. Let's just do that. The problem is that I define it as a list of coefficients, like a list of monomials that is thought to be summed. But this is totally bogus. It just doesn't work at all, because this is not going to be like commutative in any way. Maybe I don't need it to be commutative. Commutative addition. Commutative multiplication. It'll just be like a ring. I don't think I ever like use the fact that yes, I mean, like, so with the single variable polynomials, I think it's like we will want to use like commutativity from time to time. The annoying thing about the multivariable polynomials is that they sort of like don't factor at all. They're all sort of like synthetic. All the multivariable polynomials come in the form of these like sparse matrices that are really just like a bunch of like, it's basically like three polynomials like standing in a trench coat pretending to be a multivariable polynomial. Sort of this weird thing that happens. Maybe I can just rewrite the whole, I can just like do another rewrite to remove the concept of multivariable polynomials and replace it with polynomials. Like another thing that I could potentially do is redefine this, right? So the multivariable polynomials that I have, let's go back to the protocol. Sorry, I want to like search here. Sorry, no, not you. Search. God damn MV polynomial prime. Like we see that, so we have MV polynomial prime fin 2, right? It's actually only bivariate polynomial. And you can see that it's like this vector. So like perhaps a way of doing it. Fin, right, yeah. So this notation is this vector notation that constructs a vector from fin n to a. So what I'm thinking about now is there a potentiality to create an NV polynomial prime type? Instead of a sigma type, it would have a natural number, right? It's like some finite type of, like this is the type of variables. Well, my like headphones are making weird noises. I don't know what's going on. But we replace this sigma with a natural number, and we would say, okay, we're only capable of expressing multivariable polynomials on finite types, which are like, and then eval, right? Instead of taking sigma, like we would replace all sigmas with like fin sigmas. That seems possible. Let me try this. It's a little weird to have a, yeah, like what happens if I just go for it? Sorry, but let's just like totally go for it here. All the sigma types become n. Now we have a bunch of issues. All the sigmas have otherwise been removed. Okay, so like first of all, this now rather than being sigma will always be an n. That's fine. Every time sigma now appears, we should think of it as being fin n. Yeah, everything is fine. This is apparently not working. Who knows why that's not working? I don't think I have to raise any multivariable polynomial to a power here. So. And if I go back to the protocol, some problems are going to arise, but they'll mostly be right here. And I feel like I can have that. Okay, apparently I'm wrong. I do raise multivariable polynomials to a power. Shucks. Instead, I'm just going to have this be a 2. This seems kind of type class is stuck. Okay, just a moment.
Okay, and I think the mic is back on now. I don't know why that does that.
Yes, okay, we're evaluating powers. What is going wrong? Like, why? What's up? NP polynomial C1. Okay. A mol P has NP polynomial N. What? Okay, I see what the issue is. Issue is we don't like know what power we're about. Yeah, it has to be this. Yeah. Replicate and power and prime times m. Okay, that was dumb issue. Teach me a lesson for just willy-nilly renaming things. Okay, now we're going to process all of this. And presumably it would still be mad at me for the non-computable NP polynomial. Let's see what the error message is again. Okay, so now it doesn't complain about raising powers of things. But what it does complain about, let me look at the error message. Shut that down. Compiler IR check failed. At nvpolynomial_prime.eval2.at.lincheck.spec27.rarg. Error. Unknown declaration. Inst com semiring polynomial prime to semiring. Inst com semiring polynomial. I can't tell what it's angry about. I can't, like, it references polynomial prime here, and it references NV polynomial prime here. What is the problem? Why does it even matter? Compiler IR check failed. Why do you care? Like, have we reached the point where we just start we have to like do some sort of like weird ablation where we try and figure out why it's mad about this. Okay, the thing that I've learned is I can select everything. And I can go over to this file and select everything and paste. Now we have an identical file. Okay, so it's mad about lincheck. And the first thing we're going to do is delete a whole bunch of stuff from lincheck and see if that it still gets mad. Okay, we deleted a whole bunch of stuff and it stopped getting mad. What happens if we start deleting not so much stuff? Okay, did it just change? What happened? I don't know what's going on. Compiler IR check failing. Okay. Delete a little bit more. I wonder if it was something where like it stopped being able to infer types or something. Yeah, you complain here. Actually is the issue. Delete things. Check failing again. Good. Sorry, I just want to Everything else can be deleted. Error check failed. Yeah, still giving that. Still only giving that. Giving that. Still giving it. Okay, and then it stopped. So wait, just to confirm. It's giving this. Delete this. This. Okay, going one line at a time. Thinset.sum. Perhaps this is the culprit. I mean, like, I'm realizing that it's it's like thinset needs to be freaking abolished from any code that you want to run. The concept of a thinset is totally toxic to the goal of actually running your code. So if I delete this, wait, no, it still runs. Okay, but this is like still important. What was that? Thinset. Summing over some universe. Universal finite set of type thinset A. I don't know what thinset universe it is. End statement plus end wit. Okay. I just want to make a little reminder. Because thinset sum just sort of appears, right? Find set dot sum. Yes, the fact that this appears at all is very bad. So just a little reminder to myself to do Control F for inset sum dot sum and replace with list e equivalent. Okay, continuing to like find what is going on. What the heck? Compiler IR check failed. I delete this. Is this the only commit that I do? No, I do other commits here. I delete it and it works fine. Oh my god, I have no idea what could be causing that. Oh no! What could possibly be causing that? I commit? What is the complaint about? What is this error message? It's such a weird error message. Compiler IR check failed at. I mean, like, above all, they just need to make error messages that make sense. They just like, I don't know what underscore at means. Why is it therefore in the error message that I see? Like, I don't want an explanation of why it's there. I want it to be gone. Q2 commit. What could be causing it? Can I? Okay, let's try and actually remove other things. Sorry, is this used? Delete, like, let's like continue to delete things. This maybe? Okay, sorry, that was necessary. It's just gonna be an annoying thing where everything depends on things. We can still, we were able to delete that. Fine. So the only place where this occurs, I can delete it. This is the only place where this occurs, I can delete that. So the only place where this occurs, I can delete that. This doesn't occur, I can delete that. Okay, is there any way that I can... Maybe if I delete this, now I can delete this. Yeah, okay, making more progress. Q1. Q1 is simply not used. It's still the case that if I like comment these out, B1. So I believe these are of the same type, yes. Yeah, cool. Or a poly. Get rid of this by just doing this. Hat is used. Not seeing how I can delete this. This might be deletable though. And these might be deletable. And WE. Okay, this is necessary. F1 is now not used. Is R used? I don't see R being used. Getting closer and closer. It's still the case that if I comment out even this, it all becomes fine. Field F. Field F. Compiler averaging field. I mean, we can boil this down even farther. Let's not stop boiling it down. Like, this can all be deleted, yes. This, yes, that looks fine. I mean, it just has to be, in fact, it can just be like replaced. Like that. Okay. Did we manage to like remove M? I think we managed to remove M. We can just do this. Yeah, we're getting really close. It's a polynomial prime F. Maybe what I should have been doing is polynomial prime prime C, point C0. Oh my god. Okay, that fixes it. We're beginning to like understand. MV polynomial prime eval 2. Eval 2. RS type. N from type N. N to S, yes. Okay, obviously we've just defined this twice. So we should in principle be able to do this. And this. Foo. Copy, delete. Ugh. Stop. Okay. Still complaining. This weird thing. I can copy further this into here. Type class instance problem is stuck, often due to meta variables. It's because I didn't provide some type class in this commit. Statement, witness, f. Maybe if I do f equals f, f equals f. Now can I copy, paste, replace? Yep. All these things, and then this expression. I think I can delete one of these at least. No. Let me just go to the definition here. Com semi-ring. Is it because I haven't implemented it? And it doesn't know like what to do? This is a weird. Let me try implementing this and see if it. Let me try. I'm worried that it has something to do with the unused variables. Sometimes unused variables cause weird problems. Okay, what is this type? So type of R's and lists. I have no idea if this is correct, but it immediately got rid of all of the variables. See, like it's like if this whole thing is correct, it would be like super impressive for the LLM. Let's just like take a look. So P is the MV polynomial that we are mapping over. It is a list of coefficients and monomials for those coefficients. P dot map every R and S in this like in the list of all of the things that sum up to make the MV polynomial is getting mapped to f of R. Yes, okay, so f of R is being cast to whatever value it is, whatever value in S1 it is. And S is going to be a list of fin ends still. Yeah, sure. So that's that mapping. Makes sense to me. And seems like a critical first step. Yes. Then we do fold L. fold L, starting, that doesn't look right. This should be a sum, right? And like what we should be doing next is effectively summing a bunch of values in S1, which is not what it looks like we're doing. S. S is a list of fin ends. That's not really what I want. What I want to do is like further map. This is actually not exactly. Okay, so the LLM is not quite doing this. Like what I want is the f of r times s.mapg.prod, something like this. Yeah, I mean, like, it's sort of weird. I don't know if it's quite right. This doesn't look like this should be a 1. Fold L. Folds a function over the left. A. Yeah, it seems like it's taking a product, which is not what I want. What I want more is a sum. I think if this were like fold L A plus and 0, I think that would be right. But regardless, it would be way too long. What we want is to take f of r and multiply by s.mapg_prod. Then we take the sum over all such things. I think this is the correct definition. S we map through by g and take the product of all of those to get the value of the monomial. We multiply by the value of r and we sum over all monomials. That feels right. And of course, we could go on to define eval, but now let's return our attention to the MWE, restart the file. Eval2. Could it be? I mean, the thing we got rid of was the unused variables. Unused variables are usually an issue. Okay, no, it didn't. It changed. It changed what's getting at me about. That's encouraging. Usually when the error message changes, that's good. What was I gonna say? I was gonna say that usually unused variables are something that it fixed when it can't like infer types or whatever. Compiler IR check failed at list prod at lincheck spec3 rarg. Unknown declaration. Error unknown declaration. Very frustrating to get a complaint about an unknown declaration for something that is a string that does not appear in my code in any way. It doesn't, this doesn't happen when like previously this was out here. Like I had defined this as like foo. Foo. Let foo equals this. And it, like, if I delete this, compiler IR check failed. Commas everything. I feel like I just got closer somehow. Ugh. Stop. Undo. Here I am experiencing the error that I'm trying to debug. This is a polynomial type polynomial prime f. I delete this. It suddenly is okay. right, so if I if I replace this by 0 and I comment this out, okay, maybe this is like still, I still have the same error, right? Yeah, okay, so haha, we narrowed things down. None of the other stuff mattered in any way. Unknown declaration, inst-com semi-ring polynomial to semi-ring. Inst-com, okay, I need to be reading this a little bit more carefully. One aspect of what's confusing here is that we have single tick quotes surrounding this, right? So these are like the things on the outside, I'm pretty confident those are like single tick quotes. So the real value that it's not being able to find is this, which it has this inside it. So inst-com semi-ring polynomial prime to semi-ring. Why is that such an issue? Ugh, so confusing. Lin check. All this work just to make things compile. Lin check rarg. By the way, this has become, I'm also invoking this. Let me read carefully. Of all the things that I've added here, A is a polynomial prime. I think that's okay, right? F is a field, F is a field. It doesn't have anything to do with the field instance. It's just that I synthesize to semi-ring. What was the type that I provided? If I go back over here, see, I wonder if it would be like non-computable instance. I wonder if I like solved all of these. No, surely it's not that. What happens if I delete? What happens if I comment this out? Does the error message change? I don't get why semi-ring commit handle. The thing is, like, nothing is being added. Let me go. It ceases to complain. Incredible. Whereas if I go back here, just need to delete these various things. So it really is this. Why does it have to be non-computable? Compiler IR check failed. Okay, it's giving me like a similar unknown declaration polynomial to tropically bound polynomial. What? Unknown declaration polynomial prime to tropically bound polynomial. It's literally right here. What the heck? I mean, what I want this to be a function. Can I like communicate more clearly that this is a function? Fun p to this. This error I don't understand. Okay, I'm beginning to think that like it comes down to this error. Maybe I should be more optimistic about this because Because it's something I can put in a frickin' minimal working error and ship off to the people who really understand this language. It complains. Compiler IR check failed. Unknown declaration, polynomial prime to tropically bound polynomial. I have to find it right here. I don't really get it. Function injective, P polynomial. I forget what, like, uncomputable def. I don't care that it's not good. Lemma. Sure. Function.injective. Type class instance problem is stuck. It is often due to many variables. Function.injective. Okay, can I do this? This is the function that I claim is injective. What? Polynomial? What? Why don't you understand? R semi-ring R. Is it something to do with, am I handling my R value wrong? My type, implicit type, my implicitly communicated type argument. What is going on? Type class. Damn it. R is equal to R. That is what I want you to do. Now you're okay. Why? Why does that have to be? Is it not? I'm confused. P. Maybe, okay, when I delete this, P, it does not know what type it is. Yeah, okay, there's some weird thing where if I don't supply the type, it has no idea internally, like, what is the value of R? Okay. Is this something that could be solved? Okay, so like, okay, going back here, polynomial R, should this not, does this not, it knows what type it is here though. Unknown declaration. Okay, what, how can it possibly say that? I don't get it. This just seems flatly wrong. How can you be giving me an error for unknown declaration polynomial prime to tropically bound polynomial when that is right there? I'm going to copy this. Hashtag check. Okay, this is doesn't have any problem. Okay, these can both be sorry. Like, what is a minimum working error for this file? Let me think about this. The math has an MWE. Let's just go into the math MWE here. Copy all, copy, go to math, all, paste. Let's just import MATLAB, shall we? Everything afterward we will delete. We're in the MWE file, right? Yeah, we're deleting that. This is very frustrating. Semi-ring. Don't care about these, I believe. Don't care about these. We don't care about rings. We only care about the semi-ring. Small n. Sorry, we do need the small instance. What do we need? Why do we need that? It does have n as small here. Okay, let's try and be very careful. This is what I want to define. Yeah, that's fine. Failed to synthesize instance. Okay, well, it's complaining now because I deleted some. Okay, yeah, sorry. I deleted this one I should not have done. Now it can think about it again. And now the thing it's complaining about is the unknown declaration, which is right there. Okay. So the thing that has to be done is minimize this. I have the definition right here. Does this affect anything? Okay, apparently it does. Compiler IR check failed. Unknown declaration. The problem, it's like, I think what I anticipate the error, like they're gonna come back and say, yeah, this is what's actually going wrong. Ugh, so hard to get them to fix their errors. I think this is just like, I think it's just something where it's like, if I just say like non-computable, it stops complaining. You see? It just stops complaining when I say non-computable. Is it truly the case that I like in order to be able to like have an instance which is not marked as non-computable, that I have to prove all of these sorries? I shouldn't have to do that. That's dumb. Like, what happens if I literally just say sorry here for this, and I delete all of this? Declaration uses sorry. Yes, okay. But it's comfortable with it using sorry. Okay, so if I save, sorry, I don't need to save this. What I need to go is go back here. Instead of this garbage, comment this out. You will be sorry for now. Like, there's no point, there's no point, like, if there's going to be a bunch of sorries down here, I might as well do it this way. So sorry, declaration uses sorry. Okay, save. Everything in this file is fine. What happens if I go back and try and like redo this, restart the file? And more importantly, what happens if I go back here and try to restart the file here? And furthermore, just like undo some things. Ooh. It seems totally comfortable. It doesn't care, doesn't seem to care. It does like, Ooh, it's weird. It's like it realizes that there's no like sorry. It's good, right? Because this does not rely on sorry, right? This does not rely on the fact that this is like a semi-ring. It does like it only relies on the fact that we can like do the semi-ring operations. So like there should be like semi-ring and lawful semi-ring. It's like separation of like church and state. And if I look back here, okay, cool. Save those changes. If I look back here, this is like mostly happy. Cannot evaluate because it uses sorry. Mv polynomial.eval to add eval uses sorry. Does it? And or contains errors. What the sorry, like is it claiming that sorry, first of all, sorry. I believe that there's only one place where like where sorry is actually used in this file here. What happens if I remove the instance altogether? Doesn't need to be a COM semi-ring for me to do my stuff. So yeah, like the fact that it is a COM semi-ring is in fact totally immaterial to, and I never like I do not actually use that fact until I get to proving things. What has to be the case, and maybe I should think about this more, is like there needs to be a separation between the like the data and the proofs. What are you complaining? So you complain now. Failed to synthesize COM semi-ring polynomial prime f. Eval2. In eval2, you're saying in eval2, maybe this is sort of the culprit. Because it was this part that was complaining. You're saying that when I do eval2 here, I'm requiring COM semi-ring of S. But I don't need to. I don't need to require this. I just need to add and mul, right? Ooh. Have that it has 0, add, and mul. So I probably need, okay, let me think. Where am I? Here. I probably need like 0, add, mul, and 1. So prod probably uses 1. Yeah, prod uses 1. Sum uses 0. 0, add, mul, 1. This is so jank. Zero. Gosh, 0. You complain that I cannot synthesize add or mul. Add, mul. Cannot synthesize 1. Okay, now you are more happy than you were. The proofs are totally separate from the rest of everything. They're all done after. So you will do all of your you will do all of Bolton. You will do all of your computation, then you will stop computing, and then in a new file you will start to do proofs. Panic! Yes. Well, that's totally reasonable, of course. But it evaluates this. It evaluates the 44. Yes! Yes, that's the right answer! 44. I'm so good. So good at programming. Yes! Okay. Look at that. Look at that. Yes. Okay. What have we learned? We've learned that Lean is a totally awful language to program in. Never program in this language. Only do proofs. It's just totally like the concept of writing a programming language in which like some functions cannot actually be computed was a bad idea from the beginning, and we should never have gone down this path. And now we have paid for our sins. But it's okay because we've discovered that we can just program for a little while and then at some point start doing proofs and everything will be fine. At some point we're going to like have to pay the price for this, and obviously we have like panic. I mean, okay, like yeah, it panics at list.tail. The point is that it should not be this. The point is that it should be tail. This gives me a list. Return empty list for this. It should simply be this. This way. I have now not invoked the function that has the potential to panic. Okay. This is sick. Look at this 44. Oh, very good. Wow, I'm feeling quite pleased. I guess that is a good note to end on.